This podcast is sponsored by Stonefly, your trusted solution provider and advisor in enterprise storage, backup and disaster recovery, hyperconverged and cluster servers, and public and private cloud. Check out stonefly.com or email your project requirement to sales@stonefly.com for more information. Welcome back, everyone, to the Deep Dive. Today, we're really getting into something fascinating, the world of semiconductor technology. It's moving so fast.
It really is. Constant change.
And we're going to look at a pretty bold new plan that's trying to shake up how the most advanced chips get made, sort of challenging the status quo, you could say.
Definitely challenging the big players.
And for you listening, we know you want the key info, the important stuff, but without getting totally buried in jargon. So that's our mission today. Break down this potential shift, understand who might benefit and how.
Yeah, it's about understanding a potential new way forward. It starts with where we are now, though. Right now, for the really cutting-edge chips, the manufacturing process heavily relies on, well, basically one company in the Netherlands. They make these incredible lithography machines.
Lithography.
Yeah.
That's the process of printing the chip patterns, right?
Exactly. And their systems use extreme ultraviolet light, EUV, at a wavelength of just 13.5 nanometers. Tiny.
Wow. And I hear those machines are expensive.
Oh, incredibly so.
Yeah.
We're talking upwards of 300 million euros per machine.
300 million each.
Yep. So naturally, only a handful of global giants can actually afford them.
Okay, so let's get this straight. If you want to make the absolute top-tier chips for, say, the newest phone or AI system, you pretty much have to go through this one company and pay a fortune.
That's essentially been the reality. It creates a very, very concentrated market at the high end.
Right. Seems like a bottleneck almost.
It can be. But that's where this new development comes in. There's work being done in Russia, actually, on an alternative lithography system.
An alternative, how does it differ?
The big thing is the wavelength. They're aiming for an even finer wavelength, 11.2 nanometers.
Smaller still. What's the advantage there?
Well, potentially, even better resolution. Finer lines on the chip mean you can pack more transistors in, leading to more powerful, maybe more efficient chips. And crucially, the hope is to do it cheaper.
Okay, that's the hook.
Yeah.
Cheaper and potentially better resolution. But how? Going even smaller sounds incredibly difficult. What's the tech breakthrough?
It really boils down to the light source. So the current EUV tech, the 13.5 nanometer one, uses a powerful laser to blast tiny droplets of tin.
Tin, okay.
Yeah. Heating the tin creates a plasma that emits the EUV light. But this new approach, the 11.2 nanometer one, uses xenon gas instead.
Xenon instead of tin. Why does that matter?
It matters a lot, actually. When you vaporize tin, it creates this microscopic, well, debris, like soot. And this stuff contaminates the incredibly precise mirrors inside the machine.
I can see how that would be a problem, like gumming up the works.
Exactly. It means you have to stop production, clean these super delicate, super expensive optics really often. That's downtime. And it costs a fortune in maintenance.
Okay, so xenon, it burns cleaner, essentially.
Yep.
Less residue.
That's the idea. Much less contamination. So the critical components, those mirrors, should last longer. That means less maintenance, less downtime, potentially higher throughput, more operational uptime.
That makes a ton of sense from an efficiency standpoint. Lower running costs, maybe?
That's definitely part of the goal. Lower operating costs, longer component life. Now, getting there isn't instant. They've laid out a kind of roadmap.
Okay, what does that look like? How do they plan to actually build this thing?
Well, it's seen as a three-phase approach. Phase one is really the foundational science. Lots of R&D, perfecting the core tech for X-ray lithography at this tiny scale. Getting that X-ray source stable and powerful is key.
Right, the basic building blocks.
Then phase two is about building actual prototypes. These would need a really complex 6-mirror projection lens system, super advanced optics, plus powerful lasers. And they need to handle standard silicon wafers, the 200 or 300 millimeter ones.
Got it. Proof of concept, essentially. And phase three.
Phase three is the goal. Full-scale production, making machines ready for factories that want to produce chips at the 7-nanometer node, and maybe even beyond that.
7 nanometers. That's still very advanced stuff. But wait, who's actually going to buy these? You said the big guys already have the expensive EUV machines.
That's a really good point. It seems the target isn't necessarily the absolute giants, at least not initially. It looks more aimed at, say, smaller regional semiconductor makers.
Regional players, why them?
Well, think about the current global situation. There's a big push in many places for, technological self-sufficiency, building up domestic capabilities.
Right, supply chain security and all that.
Exactly. But for many countries or smaller companies, shelling out 300 million plus per machine for the current EUV is just impossible. It's too much capital.
So this alternative, if it's cheaper.
If it's significantly cheaper, it offers them a way in, a path to making quite advanced chips without that massive upfront investment. It could open up markets previously locked out by cost.
So it's about democratization, almost, making high-tech manufacturing more accessible.
That's one way to look at it, yeah.
Hmm.
And the economics go beyond just buying the machine. If the system is genuinely cheaper to run, as the Xenon source suggests it might be,
Lower operating costs, like we talked about.
right, that could make it viable to produce chips for industries like automotive or telecoms or energy. These sectors need sophisticated chips, maybe not always the absolute bleeding edge 3nm stuff, but still advanced. Often they rely on older but still complex process nodes. This could be a cost-effective way to serve those growing markets.
And of course, you can't ignore the geopolitics these days.
Not at all. Things like sanctions, trade tensions, they really highlight why countries want control over critical technologies like chip making. Technological sovereignty is a huge driver.
So if Russia develops this, it could become a supplier for its own needs, but also potentially.
Potentially to other countries, yes. Especially those who might be looking for alternatives to the established Western supply chains. It could offer another option.
Interesting. And you mentioned it's not just about cost. There were other innovations, materials and things.
That's right. It's not solely a budget play. They're apparently looking hard at using different materials in the process, like silicon-based resists. Those are the coatings used to pattern the wafers.
Okay.
And things called advanced organosilicon compounds. Plus, the 11.2 nanometer wavelength itself, being finer, might allow for more efficient pattern transfer onto the silicon.
More efficient meaning better quality chips, higher yield.
Potentially both. Higher yield means fewer defective chips per wafer, which is obviously good for costs, and possibly better performance characteristics in the final product. It could open doors for applications needing extreme precision.
So this is looking less like just a cheaper copy and more like a genuinely different technological path with its own potential advantages.
It certainly seems to be positioned that way. And if you look at the bigger picture in semiconductors, there's this trend towards, well, regional hubs and more specialized production.
Not just giant factories doing everything.
Maybe less of that, yeah. So machines designed for more flexibility, maybe lower volume runs, and definitely lower cost. They fit quite well into that kind of reshaping industry. They're not just competitors, they could actually enable this shift.
They could be real game changers then.
That's the potential, fostering a more diverse, maybe more resilient global supply chain. And, thinking about resilience and advanced tech, it brings us back to the foundation of it all, which is data, and protecting that data.
Absolutely. Which is a perfect moment to talk again about our sponsor, Stonefly. Because as chip technology advances, managing and securing the data it generates becomes even more critical.
Exactly. Stonefly is right in the thick of that. They're innovators in data solutions, everything from SAN and NAS storage.
That's storage area networks and network-attached storage.
Right, plus S3 object-compatible storage, which is huge now. And then there's backup, disaster recovery, cloud integration, and they're even pushing into AI and advanced security tech.
You mentioned security. What kind of advanced features are we talking about? Because data protection is paramount.
Oh, they have some really robust stuff. Things like immutable snapshots, basically. Data copies you can't change or delete, which is crucial against ransomware.
A lifesaver if you get hit.
Totally. Plus, strong AES 256 encryption, both for data sitting on drives and when it's moving. They do synchronous and asynchronous replication for high availability, making sure your data is safe in multiple places.
Okay.
And smart features like intelligent tiering to manage storage costs, flash caching for speed, and specific ransomware volume protection. They even hold a patent on their immutable and air-gapped storage approach.
Air-gapped, meaning physically disconnected.
Effectively, yes, creating a barrier that malware struggles to cross. They also have technologies like control and node, compass mirroring. And the neat part is you can manage all of this, even complex setups with up to 128 nodes across different locations from a single interface.
That sounds incredibly comprehensive. No wonder they're getting recognition.
They are. DCIG, a respected analyst firm, actually gave Stonefly an award, placing them in the top 5 storage companies across SAN, NAS, and object storage categories. That's quite an achievement.
Wow, all 3. So for anyone listening who's maybe thinking, my data security needs an upgrade, or we need more storage, or maybe just needs to refresh their whole setup.
Yeah, whether it's storage, backup, DR, hyperconverged systems, servers, maybe for VMware, Hyper-V, Proxmox environments. Stonefly is definitely worth checking out. They aim for affordable pricing and have a strong rep for good sales and tech support.
And it sounds like they're not just sitting still, they're growing too.
Very much so. They mentioned they're a fast-growing company, currently with over 100 job openings.
100 openings. In what areas?
All sorts: software development engineers, tech support roles, full-stack developers, digital media people, customer service. A real range. So if that sounds interesting to anyone, they can send a resume or query to jobs@stonefly.com.
Good to know. Opportunities there. And for people needing solutions now, any special deals?
Yes, they actually have a couple of promotions running. One is an immutable and air-gapped backup offer starting at just $10.
$10, that's accessible.
Seems like it. And the other is a pretty hefty appliance. 70 terabytes for backup and disaster recovery, but it's expandable way up to 4 petabytes.
70 terabytes expandable to 4 petabytes.
Yeah. It supports air-gapped and immutable backups from major platforms like Veeam, Rubrik, Commvault, Site Recovery, plus their own software. And it includes an AI appliance with object lockdown for ransomware protection. All that for $700.
$700 for that much capacity and features. That seems incredibly competitive.
It certainly sounds like a strong offer. For all the details on that or anything else, the place to go is stonefly.com or email sales@stonefly.com. They really are leaders in keeping data safe and available.
Okay, so wrapping things up, we've explored this really intriguing development in chip manufacturing, this potential Russian alternative using Xenon, aiming for finer resolution, maybe lower costs, possibly shaking up the whole industry structure.
A potential disruptor, for sure. And we've also touched on how vital data management and protection are, especially with technology advancing so rapidly.
Highlighting the solutions from our sponsor, Stonefly, from their immutable storage to comprehensive DR.
I think the real aha moment here is seeing the connection, right? How progress in making tiny, powerful chips directly fuels the need for robust, secure ways to handle the massive amounts of data those chips create and process. The two fields are tightly linked.
Definitely. Which leaves us with a thought to chew on. As we see these moves towards perhaps more accessible advanced technology, whether it's chip factories or powerful data solutions like Stonefly's, what new doors does that open? What kind of innovation could be unleashed when these tools are in the hands of more people, more businesses, maybe smaller ones?
Yeah, what happens when the barriers to entry lower across these critical tech sectors? It's just something to watch.
It certainly is. Thanks for joining us for this deep dive today.